Welcome back to section 4 of chapter 11. Now we're going to apply some of what we've learned about counting to the fundamentals of probability. What in particular? Well, theoretical probability and empirical probability. Very simply stated ahead of time, theoretical is if you can't do any actual research, you sort of do it with thought experiments and how many possibilities there are, equal possibilities. We'll get to that though. The second is actually done by research. You actually get the numbers from maybe tossing coins or whatever the situation is, and you get some numbers together and you guess, smart guess, that this kind of ratio is going to continue in the future. So here are some words you can put to various probabilities. As you can tell here, the probabilities go from 0 at the bottom to 100%. Nothing above, nothing below. So when someone's, for example, when someone says they're giving 110%, well, that isn't possible. Nor is the probability of rain more than 100% or less than 0%. These are some words that you can use: 50-50 chance, unlikely, impossible, that's 0, and a certain thing, that's a probability of 1 or 100%, and likely in the middle there somewhere. 0 to 1. The closer to 1, the more likely it's going to happen. The closer to 0, the less likely it's going to happen. Theoretical. Now, this is something for which the outcome is uncertain, and your sample space, all possible outcomes. So that's something to keep in mind. Sample space. It's a set we talked about in chapter 2, and it's all the possible outcomes lumped together. And the sample space is usually referred to with a capital S. An event is a subset of a sample space. So the set containing some event is a subset of the sample space. We'll get to some examples. One thing also to remember is that if you add up all the theoretical probabilities, you should get exactly 1, barring some round-off errors, of course. Now, this is very important. For any event, the outcomes need to be equally likely for you to get a theoretical probability. The sample space has equally likely simple outcomes. Each of those possibilities has the same chance as any other. With that said, the theoretical probability, and you can write it this way, P of capital E for event, is written like this and calculated like this. How many outcomes can occur in that particular event? This represents number of items that contain the event E, and the denominator is how many different possibilities there are in total from your sample space. So let's see how this works. First of all, let's take a look at A. Our die is rolled once. This is a typical die that has 6 sides, and you assume that it's fair, and each side is equally likely. Does that sound familiar? Equally likely to show up when you roll it. Now, what you want is the probability that you get a 3. That's our focus. So our event would be that a 3 shows up on your die. For the second, what we'll be looking at in the case of this die is our event. We'll call this event over here event 1 and this event 2. An even number could be a 2, could be a 4 in that die, or it could be a 6. And those are the possible simple outcomes put together creates an event called getting an even number. The sample space contains all of 1, 2, 3, 4, 5, and 6. If we want the probability of getting a 3, how many ways can you get a 3? Well, there's only one 3 on the die, at least on mine. And there are 6 different sides. So there's your probability of getting an event of a 3 on a die. Second part. The probability of getting an even number. Well, first of all, how many even numbers are there on the die? There's the 2, 4, and the 6. 3 of those. How many total? There's 6 sides to the die. Usually we reduce this, by the way, just like all common fractions, and there's your probability for both of those. The probability of getting a 3 is 1 out of 6, or somewhere around 16.7%, and the probability of getting an even number is 50%. Next, look at some cards. I don't know if you're familiar with cards, but usually a typical standard deck has 52 cards. There's spades, diamonds, hearts, and let's see the space. Yeah, clubs. That's the fourth one. And you have an ace, 2 through 10. You have a jack, queen, and a king. So keeping that in mind, assume that you have a standard deck. What's the probability of getting a king? So the probability of getting a king, this is your event. How many kings? Well, each of those sections of the deck has 13 cards, and one of those is a king. There's a king of each one of those parts that I told you about. So there's 4 kings in the deck. You've got 52 cards altogether, and we'll reduce that just a slight bit. 1/13 is the probability of pulling out a king if it's equally likely for any of the cards. Now, how about a heart? You have the standard 52 card deck. What's the chance you get a heart? Well, the 13 hearts, 52 cards altogether, reduce that, and the probability of a heart is 1/4. Empirical probability has to do with observation. How frequently does some event occur? You take the probability by taking how many times something occurs over all the attempts or all the experiments. So here's a table for us to use, to play with. It says one person is randomly selected from the population. What's the probability the person is female? Probability of that one person being a female. Well, look at the list up here. How many females do we have? Well, if you look at the second row, we've got 124 females. And how many do we have total? Well, the total is down here. These are females. And this is the grand total. So females 124, 242 for the total. So divide those, and there's your probability of being a female if you select one person from this particular group that we sampled. Well, folks, that's it for section 4. You've finished one more section. With a little practice, you'll be a pro at this. See you next time in section 5.